Alright, ladies and gentlemen, it's time for an update on my 2008 Trailblazer, which we are trying to build the ultimate street car with. Our goal is to go 10.00 in the quarter mile and have all the creature comforts. I'm talking heat, AC, cruise control. We're even going to have heated seats. If you guys have been following this build for a little while, you know that we are converting this car to two-wheel drive. Now, these cars originally came equipped with a transfer case and a front drive shaft and a front diff and some axles going out to the hubs, and we are getting rid of all of that junk. And you could actually buy this car in that configuration from the factory. But I wanted to go the extra mile, and today we're going to go much further in detail and show you the completed product. So let's get under the car and show you what we've done. Alright guys, I already filmed a little section on the front suspension, but I really wasn't happy with my explanation of sort of how we did this setup. So you're going to see a few spoilers in this department, but I wanted to refilm that part and give you guys a better explanation of what we did. As we teased in a previous video, we are using a G-body upper control arm. The reason that I chose this upper control arm is because it has very similar geometry to the factory Trailblazer upper control arm. We made some modifications and it now bolts in place of the Trailblazer upper control arm. Now, building a front suspension is actually a lot like adding constraints to a CAD model. Basically, every time you locate something in the car, you are defining a point in space, and you are removing degrees of freedom. Basically, there is an infinite possibility for the numbers of locations that you could put, say, this upper ball joint. But once you define one point, then all of a sudden that infinite set of possibilities starts to get smaller. And we basically keep working on nailing things down in space until we get a fully constrained front suspension. And since we already defined our upper control arm, we had a point in space sort of defined for our upper ball joint. The spindle and hub are all 4th gen Camaro, and then the lower control arm is also from a 4th gen Camaro. Now, as you can see, we've already gotten this all mounted up and attached to the car. And I kind of wanted to do the first side before we showed off how to do the second side, just so I could learn everything I needed to learn in order to provide a detailed description of what we did. So, as you can see, this portion of the frame, we notched it and we sort of grafted the suspension mount into this portion of the frame, and then the forward mount on the lower A-arm, we just made little tabs that came off of the frame. And let's move on to the other side, which I haven't started yet, to give you guys a little more detail. So the sort of base of the suspension mounts are these plates that I had cut out by Senkatsen, and you'll notice that they have these little slots in them. On a 4th gen Camaro, they literally just have a slot that the bolt sort of just goes in, and to adjust the suspension, you just move it in the slot and then you tighten it down. I wasn't really a big fan of that type of arrangement just because, you know, what if that bolt comes loose and the thing moves? And then you lose your alignment. You know, they have pretty good serration on the factory bolts. And the bushings and stuff, so I think there's a low likelihood of that happening, but I wanted to go with something a little bit more solid, so I came up with this slot arrangement and then this sort of top hat design. This inserts down into the steel piece here, but the idea with this is if I need to adjust the suspension, I can have different ones of these made that have the holes in different spots. Now, if I had been thinking, I would have set this up with 3 holes in it, just so I would have a couple choices. You know, I could do a slight offset here and a heavier offset here, and then you could flip the thing over and get a couple different arrangements, and then I could have another one made with like a hole here and a hole, you know, in between, sort of. That way you could get a bunch of different combinations. But I didn't think of that when I had this made. So I'm going to set this up so that the suspension's in the right location with a centered hole for the initial setup. But if I ever need to adjust it, then I will get more of these made and move it around. And I just really like this arrangement a lot better to have a suspension geometry that's not going to move around on me when I don't want it to. So next, let's show you off this little sort of setup jig that we have here. My dad made this out of a couple pieces of angle iron. And basically what it does is it holds the spindle and hub in a orientation so that we can kind of work with it. Now there are certain suspension geometry targets that I am trying to hit with this front suspension. And those are, I would like to see right around 7 degrees of caster angle. I'd like to see 0 camber angle at ride height, ideally. I would like to see no bump steer over the entire travel of the front suspension. And I'm obviously looking for a particular ride height. Now we move on to the portion of the frame that we modified on the other side. So this portion of the frame is actually where the steering rack sort of mounts to, and there's a couple braces off of here. So we ended up cutting this piece, which is the steering rack mount. We basically took a hole saw and hole sawed that out of here, and that will be plated back in. Then I took a angle grinder and I cut along here, and cut that out. And then we sort of grafted this shape up into this portion of the frame. Alright guys, we got our first plate welded in. Now a couple things that I wanted to show off here is I sort of intended to get this mount here as high as possible, and I also tried to tie it in with the frame in this section right here, just so that it would have a little extra strength. Now, in order to sort of determine this position, what I did on the other side is I actually played around with the location of it. I tacked it in a bunch of different places and sort of mocked everything up with my spindle here, you know, where it was 0 camber, and you know, I just played around with the caster angle until I found a location back there that seemed like a good spot. Now, some of you may not know what caster and camber are. Caster is the angle of the spindle, essentially. So the ball joint here and the ball joint up there, they will create a line between the two. And basically, the caster angle is the angle of from level that the spindle is sitting at. So normally you aim for you know, 5 to 7 degrees. So that is like this. And the idea here is that the car will basically self-center when you let go of the steering wheel, and the car naturally goes to the center. That is the effect of caster. Now, camber is basically how angled the wheel is this way. Now, in a lot of forms of racing, you actually put a little bit of camber into the car, and they would call that negative camber. And the idea here is that as the wheel pivots on that caster angle, the tire will actually sit flat when the car is turned. This would be in racing such as like autocross or road course, where you are trying to make the car go around a turn with the most amount of grip in the front. But since we only plan to drag race this, I'll show you on the other side. We target a fairly 0 degrees of camber. We don't want the tire to wear unevenly. We intend to drive this on the street a lot. So we do not want any camber angle. So now that we have our first point defined, everything gets easier from here. So we will now build the lower portion of this mount, and we can build the front mount very easily because we will basically zero everything out where we want it to be on the spindle, and we will literally build mounts to the frame there, and it just gets a lot easier from here. Alright, now that I have this wall built here that closes in the hole that we made earlier, now I can set this thing up so that we can weld in the bottom mount. So what I did to do that is I installed the control arm here and I tightened everything down. This will hold everything in orientation. I can put a bunch of tack welds on the bottom. Then I can pop this thing out so it doesn't overheat the rubber in the control arm. And I can get this thing welded in place. Then we will mount the front side of the lower control arm with those other two brackets that I showed earlier, and we should be good to go. Get it on the dry. Alright guys, the last thing that we need to figure out is the spring and strut for the 4th gen Camaro slash G-body slash whatever you want to call it setup in the Trailblazer. So I bought a set of 4th gen Camaro struts. These are just factory struts. The reason I chose to do that is because it has the mounting interface for the factory 4th gen lower control arm. Now, it just so happens that the 4th gen Camaro has the same diameter spring as a Trailblazer does, and it just so happens that they use the same eyelet diameter for the spring. The only thing about the 4th gen Camaro is the spring sort of tapers to a smaller diameter at the top. So basically what we're going to do is we're going to squish this thing down, and we're going to cut basically as much off of here as it takes to get to the larger diameter. And then that will allow us to use the Trailblazer strut top. And when we are done, it should look something like this. So This is the Camaro Strut with the Trailblazer top, and I think it came out pretty good. This is definitely a much lighter weight setup, and it fits into our combination. So let's get this other one converted, and we should have a suspended car in very short order. For the steering, I built this tubular structure here between the two frame rails, and I guess I should talk about what we actually went with right here. This is a steering rack from a 2015 Mustang, and this is something that I'm very interested to get some experience with. This is a all-electric power steering rack, and if you guys follow some of the other builds on YouTube, such as Cletus McFarland's Dale truck, they actually just put a F-150 rack, which is a very similar configuration, on the Dale truck, and they are very happy with how that is working. The reason that I wanted to go with this configuration rather than like an electric over hydraulic style setup, similar to what actually Jonathan Whitaker just did on his Trailblazer, is I wanted to keep as much electrical load off of the system as possible. With this steering rack, you are only going to have electrical load on the system when you are steering. So as long as the wheels are straight, there's no additional electric load under steering. You will have the mechanical advantage from the motor that is inside of this thing, which will help you to steer the car. This should help to reduce the additional load on the engine and help the car make more horsepower on the drag strip, as well as not create a need for like a more heavy-duty alternator or anything like that. Now, getting the dimensions on the steering rack is a pretty critical thing. Getting the pivot points for the tie rod ends and the outer tie rod end to be in the right spot is kind of a tricky thing, and we still haven't quite dialed that in fully. This relationship here with the pivots for your upper and lower control arm, that will dial in what is called your bump steer. Bump steer is when you have a toe change in your spindle. Basically, it tries to steer the car when you hit a bump or you have suspension travel. And ideally, we want the car to have zero bump steer, meaning it will not steer the car just because you went over a bump. Now, the way that the steering rack here from the Mustang works is it has a heavy power wire, a heavy ground wire, and then a switched ignition. There are also two CAN bus wires on the connector, but if you leave those two unwired, basically what the controller inside of the steering rack does is it will wait to see that CAN message, and if it doesn't see it within, I think, like 5 seconds, it goes into sort of a fail-safe mode where it will just give you normal power steering. I'm sure that the factory does some wizardry in the steering rack to make it not assist as much when the vehicle is at speed versus when it is at a stop. But a lot of people have been messing with the steering racks on like Crown Victorias and that sort of thing, and they have not had any issues with it having a weird steering feel. So I'm not really worried about, but we'll have to see how it plays out. Now that we were nearing the completion of the front suspension, it was time to start thinking about dropping in the engine. But first, we had to deal with some challenges on the oil pan. So let's go to that. All right, guys, this oil pan has taken quite a bit of effort to get to where it is, and I'm happy with the result, but it's definitely more work than I was expecting. Now, this is the Strut Engineering oil pan that he's beginning to sell. The thing is made out of steel. You can see that it's designed to hold a fair amount of oil capacity. It's made out of steel, so it's very easy to modify if you run into issues like I did. And, you know, it overall looks like a nice piece. However, there's a few things that I had to address on it, and a few things that I would suggest as changes. So first off, this oil pan was supplied to me with some known defects. I guess the guys over at Strut Engineering had a little bit of a production issue, and right here in the back of the pan, I had to modify this section to get around the main girdle of the engine. It wasn't that big of a deal. I just chucked the thing up into the milling machine and use a ball end mill to sort of machine this out a bit, and then hit it with a ball peen hammer a couple times, and then welded the hole shut, and it came out pretty decent. On his future versions of the pan, this will not be an issue. He will correct this issue. But continuing on, there was no dipstick provision on the oil pan. If you guys aren't aware, the 6 cylinders have the dipstick boss in the block, and obviously it's in the front of the engine because the vehicle came with a front sump pan. So 6-cylinder guys, we generally put the dipstick provision here on the oil pan. There was no provision in mind for that on this oil pan, so I had to add one. I went with this Canton Race Products Universal Dipstick. This thing is designed to screw in with I believe it's a 3/8 MPT bung, and you just sort of insert it here, and it has this little bubble flare here, and you screw the thing down, and then you have to sort of fill the engine full of oil, and then you cut this end here to length so that when you pull the dipstick and you read the thing, full is full. So that wasn't a huge deal, but I would love to see the production oil pans come with a provision for a dipstick, because it's nice to be able to check your oil. Now, this is very understandable. It didn't come with a turbo drain boss, so I had to weld one of those on. Not a big deal. But here's the sort of elephant in the room. This oil pan is not currently supplied with a pickup tube. And unbeknownst to me, maybe I missed it in the product literature or one of the for sale ads, the pickup tube is designed to run down the side of the main girdle and not on top of it. Now, the most logical solution to building your own pickup tube on one of these engines is to use a pickup tube from a 5-cylinder. And as you can see, the pickup tube from the 5-cylinder runs on top of the main girdle. And the 5-cylinder pan has sort of an arc to it to get over the pickup tube. The Strut pan is not designed with enough clearance for the 5-cylinder pickup tube, and therefore I had to build this little pocket here in order to have enough room for the pickup tube. Also, I had to set the pickup tube depth by adding a little bit of length. And as we usually do, I extended the pickup tube all the way to the back, and of course tapped the main girdle for the 2 hold down points. The last thing that we got to talk about is the little baffle tray inside of the oil pan. This required a little bit of modification for my pickup tube. That's to be expected. I'm not using the pickup tube that was designed to run with this oil pan. But another sort of comment I have about this baffle tray that is included with the pan is typically this tray is welded into the pan. Now, I'm not a huge fan of that, because what happens if you blow up an engine? With it welded in there, it's kind of hard to get your hands down in here and clean all the metal bits out of the pan. And I much prefer having a bolt-in tray here. Luckily, this was not welded in on my oil pan, but I'm kind of glad that it came not welded in, because that allowed me to make these little tabs here that have little threads in them so that I can bolt this thing in. So yeah, this turned into quite a bit of work, and definitely a lot more work than I was expecting. But I'm very happy with the results that we have here. So the next step is to bolt the oil pan down on with some silicone and get this thing dropped back into the Trailblazer. Another thing to talk about before we drop the engine into the car is the transmission. Now, as we've talked about in previous episodes, we are putting an 8 HP 70 into this car, and I want to go way more into detail on that particular part of the build, but we're going to do that in a later video and spend a lot of time, because I know a lot of you are very curious on how that is going and sort of the ins and outs of everything that you need to know to do that swap. For now, we are just going to bolt the engine and transmission up and drop it in the car so that we can get an idea of how the car will sit with a loaded suspension. So my dad and I knocked that out, and it was time to finally roll the car out into the driveway. And I gotta say, I'm really excited about this one, guys. Another thing that we can talk about while the engine is installed is sort of why I did all of this front suspension rework. Now, a lot of you think that I'm crazy. You think that all of this work is an absolute waste of time, and you think I'm just smoking drugs or something. But let me urge you guys that no, I'm not crazy. Well, maybe a little. But there is a reason behind the madness. And the reasoning for all of this suspension rework is right here. Now, as I said, we had some issues with this oil pan, but the fruits of our labor are soon to pay off. Now, as you may or may not be aware of, these engines came with a front oil sump. And the problem with a front sump is that all of the oil is in the front of the engine, obviously. Once you accelerate the vehicle, the oil in the sump is going to want to run away from the sump, and your oil pickup can come uncovered, and you could start sucking air. Now, there are some guys that are running front sumps and having a lot of success in a lot of forms of racing, but I'm just not interested. I really don't like to fix broken stuff, and I really don't like destroying engines for no reason. This is the reason that I wanted to go to a rear sump oil pan. The oil will be in the back of the engine, and it will be far less likely for that oil pickup to become uncovered, and the engine should be much more reliable. Now, funny enough, somebody makes a rear oil sump conversion kit for a Trailblazer that doesn't require any suspension rework, and it keeps the steering rack in the original location. The problem is that rear sump conversion kit comes for the SS, the dreaded LS-equipped Trailblazer. And it requires that you run a Corvette LS3 oil pan, which has a very shallow sump, in order to keep it above the steering rack. I am not a fan of this solution. Those oil pans are known to have oil control issues, and I wanted to eliminate the problem completely, not just band-aid it with some sort of really shallow sump. And that required us to do all of this rework. The benefits of all of this work here don't stop with just the oil sump. We're also going to see a significant weight reduction. We are going to some more lightweight, sports car type suspension components, and as I've mentioned in previous videos, we're going to a 5-lug spindle, which will allow our wheel selection to get significantly better. And while we're on the subject of wheels, let's show off what we picked up for that. For the front wheel, I decided to go with what you see here. This is a new wheel that Summit Racing just came out with. It is their Venom series wheel. It is a cast aluminum construction, and it has sort of that 5-spoke design. I've always been a 5-spoke wheel type of guy, and I'm really happy with the quality and the overall look of these wheels. I think they look fantastic on this car. So that is what we decided to go with there. And while I have the camera pointed here, I want to give a shout out to somebody in the comments in one of the previous videos who sort of made a good suggestion. As we teased in a previous video, we were going to run a much more narrow wheel and tire setup, and they mentioned that we should really look into the load rating of the tire. The load rating is actually right here on the tire. This 97, that refers to the load rating. And the previous tire setup, which was a 15 by 4.5 setup, with a, I believe it was a 165 70 R15. Those tires had a much lower load rating. I think it was around 1,100 pounds per corner. And since this car is probably still going to weigh right around 4,400 pounds, and it's likely to be nose heavy, if we take that 4,400 and divide it by 4, and then add a little bit for that front bias, we're definitely going to have a problem. And therefore, it was a necessity to go to a wider wheel and tire, just because I couldn't really find an affordable tire selection for a narrow wheel and tire setup like we were going to try to do previously. So we went with this. It is a 15 by 7 and a set of 205 70 R15s with a 97 load rating. I believe that's right around 1,500 pounds of load, so we should be good to go there. For the rear tires, we are going with a 15 by 10 with a 255 drag radial, and I'm super happy with how this is coming out. And like I said earlier, we have gotten away from the 6-lug pattern on all 4 corners, so it is really easy to find a nice wheel selection like what we have here, and it is much more affordable. Alright, I hope you guys are as excited about this project as I am. Make sure that you like, comment, and subscribe, and we'll see you in the next one.